So we're going to be solving quadratic equations by taking square roots. You know what a square root is already. Like square root of 4 is 2, square root of 9 is 3, all that sort of stuff. We're also going to be looking at imaginary numbers and what that means when it comes to solving. So if you've ever seen the letter I used in math, normally it's written like a little curvy I like that. That's an imaginary number. We'll get to that during this lesson too. So first thing you need to know is that there's really three ways, at least three ways that you could solve. So we're going to solve x squared equals 16. We're going to solve it three different ways. First, you can solve it by graphing. And if you want to solve by graphing, you could use a graphing calculator. You go over and you're going to type in the equation. So it said x squared equals 16. There's two ways you can do that. You can enter each side of the equation as its own separate graph. So you could do this left side as y1 and the right side as y2. Or you could rearrange it and you could do move the 16 over and do x squared minus 16. Doesn't really matter. I'm going to do it separately, left side and right side. So for y1, we're going to enter x squared. So for y1, you enter x squared. And for y2, we enter 16. So on this graph, the way it is right now, we can't see up to 16 because it stopped at 10. So I'll scroll it up a little bit. There we can see 16. Now, if you're solving by graphing, you're just looking to see where they intersect. So they intersect these 2 points right here. Your calculator could give those to you if you just push G-solve on a Casio. And we want the intersection, so that's F5. It gives you one of them, -4, 16, and then the other one is +4, 16. So you can graph these. I'll even regraph it here on paper. Pretty bad curve, but gets the job done. And then 16 is that flat line right there. So they intersect at those 2 points, -4 and +4. -4 and +4. You could say x equals +4. That would work too. Another way you can solve this is solving by factoring, in which case you have to move the 16 over first. So if you move that 16 over, you subtract 16 from both sides. It then equals 0. And then you factor that problem. So x squared minus 16. It's a difference of squares. There's only the two terms. So you get x plus 4 and x minus 4. And then you set each factor equal to 0 and you solve it out. So if you solve this, x plus 4 equals 0, you get x equals -4. If you take x minus 4 equals 0, you get, add the 4 over, you get x equals positive 4. Same answers, because it's the same question. And then the last way, which is for this particular problem, probably the easiest way, you can take square roots. So you take a square root to get rid of the x squared. It just gets an x. And you take the square root of the other side. Square root of 16 is 4. The only thing you have to remember is that when you do square roots, you're always going to get both a positive and a negative. So you can put them together as plus or minus. But all three ways work the same way. Solving by taking square roots, pretty easy if it's just an x squared. There's no like x term, linear x term. But the most important thing you remember is that when you take square roots, it's always plus or minus. So we're going to do some more. Just solve by taking square roots. When you do that, you need to get the x squared by itself first. So to get x squared by itself, we can move the 16 over. So add 16. And then we got to get rid of the 2. So we're going to divide by 2. And then we're trying to get rid of the squared. So we take the square root. And you have to remember to do plus or minus. And square root of 8 doesn't work out perfectly. So if you remember doing these little factor tree things, 8 is 2 times 4, 4 is 2 times 2, and then you're looking for pairs to take them out. So you can take out a 2 because there's a pair of 2's, and then you have a leftover 2 that goes back inside to simplify square roots. It wouldn't be totally wrong if you said plus or minus the square root of 8, but it would be unfinished. So example B, we're doing the same thing. Get the x squared part by itself by moving the 9 over. Subtract 9 from both sides. And then get the x squared by itself by dividing. Negative divided by negative is positive, so that's 9 over 5. And then we're trying to get rid of the squared, so we're going to square root it, which means we're going to have to do plus or minus. We'll get x equals plus or minus. When you're doing the square root of a fraction, you can do the numerator and denominator, the top and the bottom separately. So square root of 9, square root of 5, you can do them separate. So square root of 9 for the top, the numerator, is 3. And then square root of 5 does not reduce, doesn't simplify, it's just square root of 5. Some places you'd read that that's not okay to leave the square root on the bottom, square root in the denominator, but it doesn't help if you change it around at all in this case. It doesn't actually simplify it, so I would leave it alone. So you go through number 3, you should get to x squared equals plus or minus square root of 24, but then you have to break down the 24. So going through that again. 6 times 4, 6 is 3 times 2, and 4 is 2 times 2. You keep breaking them down until you get to prime numbers. You can't break them down anymore. Then you look for 2 of the same number. You got 2 2s. If you get 2 of the same number, they get to go outside. And then the 3 and the 2, those aren't the same, so they can't go outside. They got to go back inside the square root. And when you do that, you can multiply them back together. 3 times 2 is 6. So when you break it down, you go all the way down to those primes, all the way down to 3 times 2 times 2 times 2. And if you have 2 of them, it gets to go out. If you had 2 sets of 2 that got to come out, you would multiply them together, just like we multiplied the 3 times 2. But if they were pairs, they get to go out, you multiply them on the outside. So then for number 4, you would move the 13 over, you would divide by the 4. You get x squared equals 13 over 4. You square root both sides and do the plus or minus. And then just like we did up on that last problem, when you are square rooting a fraction, you square root the numerator and denominator separately. So the square root of 13, you can't do anything with that. That's just a square root of 13. It doesn't even break down because nothing multiplies by 13. Square root of 4 is just 2. And that would be your final answer. So imaginary numbers, they're not real, which means you can't, that's why they're imaginary, which means you can't see them. Just like your imaginary friends, you can't see your imaginary friends. Well, maybe you can't, but normal people can. So you can't see these. The only place you see math is in a graph, which just means you don't see them in a graph. That's all that means. But everything else works out with it. So you're going to get imaginary solutions to something like, let's talk about this problem first. If x squared equals 4, what does x equal? 2 or negative 2, plus or minus 2. You take the square root. 2 squared is 4, and negative 2 squared is 4. The whole idea of imaginary numbers came about because some mathematician, doesn't matter who it was, spent a lot of time thinking about problems like this. X squared equals negative 4. All I do is change that little negative. It feels like that should work. Should be able to solve that out. Even though you can't see that on a graph. If you try to graph it, it won't work. But it feels like that should work. So he went through and he did a bunch of work, and he ended up figuring out that if you do this, and you call that little negative 1, thing, you would square root both sides. I guess I'll do that first. You get x equals the square root of negative 4. But you think about it a little bit different. You think about that negative 1 separately from the square root of 4. It works out because we know the square root of 4 is 2. But we just have this little square root of negative 1 thing that he didn't like. So he said that's the part that messes this all up. So let's just call that I for imaginary. Because you can't see it. You can't see it on a graph. But all the math works out. Just the graphing is kind of weird. So you call the square root of negative 1 I, and then it works normal. So just a couple quick examples. We know that x squared equals 4 has answers of plus or minus 2. So x squared equals negative 4 has answers of plus or minus. The only thing is that negative, so it's just 2i. So that means x squared equals 16. We have two solutions for that. X equals plus or minus 4 when you take the square root. If you change that to x squared equals negative 16, it's the same problem except for that silly little negative, which just makes it imaginary. So it's 4i. The only thing that you need to remember is if you have I squared, it's negative 1, so it's going to make a negative answer. It's kind of the follow-up of I being the square root of negative 1, I squared is negative. So we can solve a little bit harder questions the exact same way that we were before, except this time they're going to be imaginary. So, for example, A here, we're going to move that 12 over. We're going to take the square root and solve it out. So you get x squared equals negative 12. And then we're going to square root both sides. When you do that, you got to remember you're going to get a positive negative, plus or minus. So this negative that's inside the square root, all that does is it's going to put an I in our answer. That's it. Since it's a negative, it's going to be an imaginary answer. We still do the square root of 12 the way we would always do square root of 12. Which means we have to break it down to be 2 times 6, 2 times 3. So when you break it down, you get a pair of 2's. Pairs get to come out. We have the 3 left over. That has to stay inside. And then the I comes out. Or the I is there, I should say. We just keep it there. You can put it at the end. You can also put it here in the middle. Wherever you want it. It doesn't matter.